Hello, welcome to this video. In this video, we'll solve one more problem on steady flow energy equation or first law applied to open systems. So, let us read the problem. In a steady flow apparatus, 135 kilojoule of work is done by each kg of fluid. So, in a steady flow apparatus, that is a hint that it is a steady flow energy device, or we'll have to use steady flow energy equation in order to solve this problem. 135 kilojoule of work is done by each kg of fluid. We know the sign convention. When work is done by the fluid, it is going to be positive. So, plus 135 kilojoule, I will convert it into joule. And remember, he has said that per each kg of fluid. So, it is joule per kg. The specific volume of the fluid, pressure and velocity at the inlet. So, he has not told what device it is, but still a steady flow device we can imagine. So, there is an inlet and there is an outlet, and we are talking this as 1, inlet as 1 and outlet as 2. So, he is telling you specific volume small v, we denote it by small v, 0.37 meter cube per kg at the inlet, 600 kilopascal. So, P1, remember we want pressure in Newton per meter square. So, 600 into 10 power 3 Newton per meter square, and velocity is capital V, 16 meter per second, and the inlet is 32 meter above the floor level. So, let us say if this is the floor level, inlet is 32 meter floor above the floor level, or he is also saying that because the second statement says discharge pipe is at the floor level. Now, let us say discharge pipe, I will keep it at the floor level. Okay. So, this is the floor level he is talking. So, this itself is the floor level. So, this is our steady flow device. Okay. So, Z2 must be 0 now, because at the floor level, and Z1 is the distance which is 32 meter above the floor level. Okay. Now, that is what is given. Z1 is 32 meter, and on the other hand we have Z2 is 0. The discharge condition are, so at outlet volume is 0.62 meter cube per kg, pressure is 100 kilopascal, and velocity is 270 meter per second. And he is also speaking about the heat loss. Total heat loss between inlet and discharge is 9 kilojoule per kg of fluid. So, there is a heat loss. Now, whenever heat loss we talk, heat loss is minus, because heat loss from the working fluid is considered to be negative. So, 9 into 10 power 3 joule per kg. Okay. In flowing through this apparatus, does the specific internal energy increase or decrease, and by how much? So, he is asking you whether U2 minus U1. So, this is what we call as specific internal energy. We will see whether it is increased or decreased based on which, whether we get negative or positive answer. Okay. So, now let us start with the equation which we know. Heat transfer, I will write per kg. So, small q, W is equal to change in enthalpy plus change in kinetic energy plus change in potential energy. Alright. Now, q, yeah, this is small q. Whenever we talk about per kg, specific properties are denoted by small letter, that is it. So, there is no mass flow rate is given. So, everywhere this has to be in joule per kg, and this will get it in joule per kg. If we are having this, has to be in joule per kg, this also has to be in joule per kg, and so on. Alright. Okay. Now, q is minus 9 into 10 power 3 minus this work transfer is 135 into 10 power 3. Enthalpy is not known. We can write it like U2 plus P2 V2. That is what he has asked you, U2 minus U1. So, I will keep this H2 minus H1 as it is, and I will try to find out H2 minus H1 first. Okay, plus change in kinetic energy half into V2 square minus V1 square. So, half into V2 square minus V1 square. So, I will expand this equation here, then I will substitute it, half into V2 square minus V1 square plus G into Z2 minus Z1. Now, in this place I am substituting now half into V2 square, capital V, remember 270 square minus 16 square plus 9.81 into Z2 is 0 and Z1 is 32. Now, this equation can be solved in order to get the value of H2 minus H1. So, I will substitute H2 minus H1 as X and I will get the answer for H2 minus H1, and remember we will get it in joule per kg because every other quantity is substituted in joule per kg and this was supposed to be substituted in joule per kg. Alright. Minus 9 into 10 power 3 minus 135 into 10 power 3. Now, this is the unknown. Alpha equals unknown, I will substitute it as X. So, alpha X plus half into plus I will open a bracket here plus half into 270 square minus 16 square plus 9.81 into 0 minus 4. Now, I will solve this, shift solve for x is equal to 0 and this is our answer. That is minus 180 H2 minus H1 minus 180 into 10 power 3. 0.28, yes, minus 180.28 or minus 180.3 into 10 power 3 joule per kg. But remember, we are not asked to find out the enthalpy, we were interested whether the internal energy increase or decrease. And remember, this H2 minus H1 is what? U2 plus P2 V2, this is H2, H is U plus PV and H1 is U1 plus P1 V1. This is minus 180.3 into 10 power 3. Now, I will separate this U2 and U1 here, U2 minus U1 plus this P2 V2 minus P1 V1. This is minus 180.3 into 10 power 3. Now, these all values are given, only unknown is U2 minus U1 plus P2 is 100 into 10 power 3, V2 is 0.62 minus P1 is 600 into 10 power 3, V1 is 0.37. That should be equal to minus 180.3 into 10 power 3. Now, let us find out this value U2 minus U1. I will unknown U2 minus U1. I will consider this U2 minus U1 as the unknown and substitute it as X in our calculator. Let us see what we will get. Now, the first term is alpha X. You can solve it by manual way also, or you can choose this method, alpha X plus the first term is 100 into 10 power 3 into 0.62 minus 600 into 10 power 3 multiplied by 0.37. I will close this bracket. This must be equal to, so alpha equals minus 180 into 10 power 180.3 into 10 power 3. So I have typed the equation as it is, and now I am going to solve it. Shift solve for x is equal to 0 equals. So we are getting minus 20.3 into 10 power 3. And this has to be in joule per kg because every other unit are in joule per kg. Now what does it indicate? So it simply indicates that if we are getting negative value, this must be greater than this. So U2 is lesser, U1 is higher. So that is what negative value indicates here. What is our comment now? Does the internal energy increase? No, it decreases. U2 is lesser. So internal energy decreases. All right. Thank you.